Okay, let's look at the homework 17, problem number 4. Alright, so let's first look at the path. So it's, let's say, semicircular path from 0, comma, negative 10 through 10, comma 0, then to 0, comma 10. Alright, so let's draw the picture. Alright. So it's going to look like this. So it's going to go, let's see, so this is the x-axis, and here's the y-axis, and here's the origin, and it's going to start from 0, comma negative 10, so it's going to be right here, and then hit point right here, 10, comma 0. And 0, comma 10, so it's going to be up here. So it's going to take a circular path along this semicircle. So whoops. So it's going to look somewhat like that. All right. Then just like the other problems, I'm gonna just add the extra path here to make it a closed curve. Right? So let's call that closed curve C prime. Right? So this is C prime. Right? Then instead of doing just the C, let's do the C prime. So that's the closed curve. So integral over C prime, which is a closed curve of this guy. So y e to the x minus 1 dx plus e to the x dy, right? So we know that this is our, so this guy right here is our p, and this guy right here is going to be our q, right? By Green's theorem, we have double integral, right, over this region. So I'm going to call this a semicircular region, right? Let's call it A. So this is over that region A. And the partial q with respect to x would be e to the x minus partial p with respect to y would be e to the x. Alright, dx, dy, but these cancel out, e to the x, so it's going to be an integral of 0. So therefore, this guy is going to be 0. Right? Right. This indicates that the vector field f, which is y e to the x minus 1 comma e to the x, is conservative. Right? So therefore, we can actually take a simpler path. So for example, in this case, I would probably take the path from here along the y-axis straight to 0, comma 10, right? So the integral that we are looking for, so I'm going to call it I'm going to just go straight from here to there, right? So in this case, there's no change in x, so we don't have to look at this guy. So only change would be y. So we're going to look at dx, e to the x dy. But along this path, x is always 0, which means that you have a e to 0, which is 1, dy, and y goes from negative 10 to 10, right? This is a really simple integral to evaluate, so I'll let you guys finish that. But this integral is going to give you exactly the same integral as the line that go along this semicircular path. All right, that's it. I hope that this was clear.